Hey everyone, we're back with another video as part of our take-home science kit series. This week we're going to be talking about our radiation experimentation kit, more specifically about where radiation comes from, more specifically UV radiation, how it gets here, how it can affect you, and another activity that you can do with those UV reactive beads that come in the kit. You can also buy those beads online. There's a link in the description below. Or you could also come to the museum when we open up and maybe we'll have them out for you to play with on site. But this is a longer video. There's some science to get into. So let's go ahead and get started. This is our sun, a giant ball made of fire, fueled by nuclear power inside of it. It's so powerful that it's shooting out energy of all different types. These types of energy come from what's called the electromagnetic spectrum. Basically, energy travels like a wave on the ocean, which is why the different types of energy are determined by their wavelength. The smaller waves are all bunched together, and those are things like gamma rays, X-rays, and ultraviolet light. They're so small that we can't see them. The smallest type of energy we can see with our eyes is the color violet, which is why the next smallest energy is called ultraviolet. The bigger waves are more spread out, and get so big that after red, our eyes just aren't cool enough to see them. Since their frequency is so big and far apart, we call the next lowest energy infrared. Now, we do have special cameras that are able to see some of these energies. Here is a picture of our sun using special cameras that can see energy like ultraviolet light and X-rays instead of the colors that we can see. The yellow and red colors are used to highlight the UV radiation, which gets more dangerous the farther away it is from visible light. The green and blue colors are used to highlight powerful X-rays, which you can see are front and center in the powerful solar flares across the surface of the sun. These images from NASA of the sun are taken with 6 different ultraviolet cameras, allowing us to see more clearly the high-energy solar flares, which are filled with dangerous UV energy. The sun is always shining UV radiation at us, but sometimes these solar flares can blast us with more than normal. Luckily, we have an atmosphere that works to save us in several ways from this radiation. Our atmosphere is made of 6 important layers: the exosphere, which blurs the line between atmosphere and outer space. There's the thermosphere, which actually absorbs most X-rays and the smaller, most powerful ultraviolet waves. It's also where the space station is floating. Next we have the mesosphere, which is where atoms in the air are close enough together that they can create lights like the aurora borealis when they get hit with particles from the sun. Next we have the stratosphere, which is actually the highest level where we can find bacterial life. Then we have the ozone layer, which is technically within the stratosphere. This layer is like a second thermosphere because it also filters out more of the dangerous UV light that has small wavelengths, thanks to special oxygen molecules called ozone. Finally, we have the troposphere, which is where all of our clouds and storms are, and where we live. Down here, we only get a tiny fraction of the dangerous UV radiation from our sun, thanks to the ozone layer and the thermosphere. That little bit of UV radiation can still be enough to do damage, though. As it hits your skin on a sunny day, the smaller UV radiation that makes it through the atmosphere, called UVB, hits your skin. That UVB can get you a tan in small amounts, or give you a sunburn if you're out too long. But it also helps your body produce vitamin D, which helps you grow big and strong. UVA radiation, on the other hand, mostly gets through the atmosphere without a problem, and can actually go deep into your skin. When the UVA radiation goes deep into your skin, it can hurt your DNA, and over time, could make you really sick. So, when you're outside on a sunny day, and you have a bracelet or necklace made with UV-reactive beads, keep an eye on them. The lighter they are, the safer you'll be. You can actually test out sunscreens by putting different types on different beads, and see how they change color. When they get really dark, especially in the summer around noon, you should consider at least putting some of that sunscreen on, so you don't get burnt. We hope you enjoyed this video. Please like and subscribe for more videos from Dan, Liza, and Amelia.